The Azure OpenAI Prompt component uses a large language model provided by OpenAI to get responses to user-composed prompts. This component enables you to take one or more input from your source table, combine the inputs with your user prompt, and send this data to the large language model for processing. You can configure the component to output the results as either a text value or a JSON object. The results will be stored along with other metadata in a destination table on your cloud data warehouse. Through the Azure OpenAI Prompt component, you can use Retrieval-Augmented Generation, known as RAG. Using RAG optimizes a large language model output by invoking a knowledge base outside of the large language model's initial training data sources. By using RAG, you can extend a large language model's capabilities to specific domains, such as your organization's documentation, without retraining the large language model. In this example, we'll use the Azure OpenAI Prompt component to get answers to user queries on the Data Productivity Cloud platform using OpenAI's GPT-4 model. We have a Pinecone database which is populated with Data Productivity Cloud documentation to help provide context to the large language model to answer these questions. We will connect to OpenAI's embedding model to generate embeddings for the user queries, using the Retrieval-Augmented Generation option to perform a nearest neighbour search on our Pinecone vector database. This will find appropriate documentation and send all of this information to the large language model for processing. Finally, retrieving answers to our customer questions and writing them out to a new table. So in this example, relevant Data Productivity Cloud documentation has already been vectorized and stored in a Pinecone index under a namespace, which you can see here. Okay, moving to the Azure OpenAI Prompt Component's properties. Under the Connect section, enter your URL endpoint for access to your Azure OpenAI deployment. You can find this in the Keys and Endpoints section when examining your resources in the Azure portal. Then enter the name of your Azure deployment model and select your API key for your Azure account. In the source properties, define the source database, schema, and table which contains the queries to be answered by ChatGPT. This is a table of questions relating to how to use the Data Productivity Cloud. So for example, questions like, can you explain how to configure the S3 load component for loading data into a cloud data warehouse? You can see the table of our questions here. So moving to the configure properties, this is where you enter the context for your query. So for example, you'd need to enter a persona, which is who or what the model should impersonate when contextualizing the generative responses. A context, which is the situation for the model to enhance its responses, and a tone, what kind of language do you want the model to use? So now moving to the input section, select just the column that contains the question from our table. So in this case, the column containing the questions is called Query. Here you can also choose the output format for your data. You can choose either text or JSON. In the destination properties, define the target database, schema, and table where the output data will be stored. The table we'll write our data out to is called Component Queries Azure OpenAI RAG Output. So now we've chosen our OpenAI model, our source data, our context, and a target table. It's time to configure the Retrieval-Augmented Generation settings. Use the RAG config section to enable RAG, which will reveal additional properties which we will populate now. Use the pretext field to add text to your large language model prompt before the RAG data is listed, thus instructing the large language model what to do with the RAG data. Under search term, choose a column in the source table that contains a search term for the vector database. Again, this is our query column, which contains our customer questions. Enter your embedding provider, in this case OpenAI, and your API key for this account. Select the embedding model, in this example the text embedding ADA002 model. You must use the same embedding model for the search string as the one used to generate vectors for the documents stored in your vector database, which for this example is text embedding ADA2. If we switch over to Pinecone, here we can see the embedding model we've used in the metadata. Next, we need to connect to a vector database, and here we'll select Pinecone. Enter the credentials for your account in the Connect section of the properties. We'll also enter the Pinecone project, index and namespace. In this example, the namespace is demo component docs. If you leave the namespace blank, then the search will be carried out on all the namespaces in the selected index. The top K property is where you define the number of closest matches we want our query to return. In this example, we'll select 2. Now that we have our closest matching vectors, we need to identify where the raw text data associated with these vectors is, so it can be sent to the large language model. In the Configure section, under the Data Lookup strategy, there are 2 options. Either raw data in metadata, which means your raw data is stored in key value pairs in the Pinecone vector metadata, or table details in metadata, which instead means that the source table location, including database, schema, and table name, are stored in the Pinecone metadata. For this example, we're using table details in metadata, where if we look again at Pinecone, we can see the database, schema, and table names defined in the metadata. Now, our Azure OpenAI Prompt component is set up and we're ready to run the pipeline. After you've validated and run the pipeline successfully, we can go to our destination table we defined, which was Component Queries Azure OpenAI RAG Output. Now, looking at the data in our table, we can see the answers to our questions. The data includes all the context and format we provided using ChatGPT in the Azure OpenAI Prompt component. And a breakdown of the data in the table includes the answers to our question in the data column, and the table also contains data for prompt tokens and completion tokens, as well as error details and the original user and system prompts. For more Data Productivity Cloud videos, please subscribe to the channel. And to get started with Matillion, visit matillion.com.